Describe the construction of DC machine. OR. Describe the construction of DC motor. OR. Describe the construction of DC generator. Three are same. Three are same construction. Again, once again, I want to discuss. The first question is question 1. Describe the construction of DC machine, 10 marks. Otherwise, the same question. Describe the construction of DC generator. Next question, the same question again. Describe the construction of DC motor. Three are same. I don't know. One. Yesterday we have discussed, no? Here write down the topic. Yesterday we have discussed, write down that topic. Clear? Right. Third question comes under derive the EMF equation of a DC generator. Derive the EMF equation of a DC generator. 5 marks question. 5 marks question. Clear? So what is the formula we have discussed today? EG is equal to P into 5 into N into Z by 60 by A. This is the formula. We have to derive this one. Derive the EMF equation of a DC generator. What is phi? Flux in Weber. Flux in Weber. What is P? Number of poles used in the design. How many poles you have used? 2 poles, 3, 4 poles, 6 poles, 8 poles in the design of a DC generator. In the design of a DC. How many poles you have used? That is called P. That is called P. Flux. Phi means flux. Flux in Weber. Flux in Weber. What is N? Speed of the armature, which rotates in the magnetic field. Which rotates in the magnetic field. Speed of the armature, which rotates in the magnetic field. How much speed you are rotating? You are rotating with 1000 RPM, 1200 RPM, 1400 RPM. In which speed you are rotating? The armature in the magnetic field. In the magnetic field. That is called N. That is called N. What is N? Speed of the armature in RPM. Units enti? What is the units? RPM. Rotation per minute. Rotation per minute. Next, come to Z. What is Z? Number of conductors which is placed in armature slot. Which is placed in armature slot. We are placing the copper wire in the armature slot. We are placing the copper wire in the armature slot. Copper wire means armature conductor. What is armature conductor? Other name for armature conductor? Armature winding. Armature conductor, armature winding. It is made up of copper. It is made up of which is placed in armature slot. Which is placed in. So how many conductors have you placed? How many conductors have you placed in the slots? How many conductors have you placed in the slots? So this is called Z. This is called Z. Now A. What is A? Parallel path. Two designs. You will mention in the problem. The design is for lab connected. LAP, lab connected. You will mention in the problem that it is lab connected design. It is wave connected design in the problem. If it is a lab connected, A is equal to P. It depends upon the P. If it is a lab connected, A is equal to P. A is equal to P. If I say poles is 4, what is A? 4. If I say pole is 8, what is A? 8. It depends upon the poles. If it is a lab connected, it depends upon depends upon the poles. Depends upon the poles. If the pole is 8, then what is A? The design is 8 poles. If the design is 8 poles, what is A? 8. You have to take 8. Confirm. If it is a wave winding design, if a wave winding, in the problem we will mention wave winding. In the problem we will mention wave winding. Then A is equal to 2. Always 2. It does not depend upon the poles. It does not depend upon the poles. For example, it is a lab winding design. P is equal to 8. It is a lab winding wave winding design. It is a wave winding design. P is equal to 8. Then what is A? 2. Confirm 2. It does not depend upon the pole. It does not depend upon the wave winding. Does not depend upon the pole. It is a constant one. A is equal to 2. But lab winding, it depends upon the poles in the problem. In the problem. So this is called EG is equal to. Now we have to do a small problem on this one. I will give one design to you. I will give one design. How many poles are there in the design? What is the flux flowing in the design? How much speed armature is rotating in the magnetic field? How much with what speed armature is rotating? I'll give some design. You find out how much voltage has been generated in the copper wire. How much voltage has been generated in the copper wire called conductor. Called conductor. We'll give one design. Clear? Write on the design. First problem one. Find the find the problem one. You got this one in the exam, previous question paper. You got it in the exam. You do by yourself. Clear? Write on the formula, given data, write on the formula, get the answer. Right. Find the find the EMF generated. Find the EMF generated. Find the EMF generated by a 6-pole DC generator. By a 6-pole DC generator. Find the EMF generated by a 6-pole DC generator having 440 conductors, having 440 conductors, having 440 conductors, and drives at a speed of. Please all of you note on the problem. Please all of you note on the problem. You have to do the problem now. Please note on the problem. Having 440 conductors and driven at a speed of 1400 rpm and driven at a speed of 1400 rpm, connected as lab winding and wave windings, connected as lab winding and wave windings. The flux per pole is 0.032 Weber. 0.032 Weber. This is the design of a problem. Now your target to find out voltage in the conductor. How much voltage has been induced in the conductor called copper wire? Copper wire. You have to find out. Write on the question. Completed question, all of you. Right. Now make a given data heading. Heading given data. What is the given data from the problem? What is the first one? How many poles of the design? 6 poles. He has taken 6 poles design. He has taken 6 poles design. He has taken 6 poles design. Now, how many conductors he has for the armature? Total number of conductors for the armature 440. Z is equal to 440. Z is equal to 440. How much speed the armature is running? N. N is equal to 1400 rpm. Armature is rotating with 1400 in the magnetic field. In the magnetic field. We have given the design. I am rotating with 1400 rpm. I am rotating with 1400 rpm. Still, what is the given? Flux 5. 5 he has given. He has given the 5. This is the given data. This is the given data. Clear? Only this he has given this data. Now write down the formula and make a box for the formula. What is the formula? EG is equal to 5 into P into N by 60 into Z by A. Or you can write down total. 5 into P into Z by Z 60A. 5 into P into N into Z by 60 into A. So you know P, you know 5, you know N, you know Z. What is A? Heading, A bit. Make it A bit, A bit. Lab winding. First one is A bit. Lab winding. A bit. Heading, lab winding. What is A? 6. What is A? 6. Apply the formula. Apply the, get EG. Please apply the formula, get EG. A bit. Lab connected. Heading. A bit, lab connected. A is equal to 6. A is equal to 6. lap winding A is equal to P. A is equal to 6. A is equal to P. A is equal to 6. Get me the value of EG. How much voltage has been generated? How much voltage has been generated in the conductor, copper wire, so that current will flow. So that current will flow. Anyone answer? Is it correct answer? My calculation is correct? It may be wrong also because huh? Right, 328. Okay, 328. It was printing mistake. You tell me you got the same answer 298 or 328. Anyone? It was printing mistake maybe. And the 328. I have taken four. I have done the mistake. I have to take 440 here. I have taken 400. Printing mistake. It is a printing mistake. Get the concept. Only get the concept, please. Get the concept. Actually, it is 440 here. It should be a 440 here. The problem is 440. But what I have taken? 400. So it is we got 298. We got a 290. It is 440. The answer is 328. The answer is 328. Clear? 328 volts. 328 volts. 328 volts. Volts. You have to write on the volts. You have to write on the volts. If it is completed, what kind of design it is? Lab connected design. Now I will change the design. Now I will change the design. The same problem, but design is different. What is the design? Bit. Wave winding. Wave winding design. A is equal to wave winding. A is equal to 2 fix. Bit. Wave winding. A is equal to 2 fix. Get the answer. Here it should be 440. It is a printing mistake. I've gone for 400. What is the voltage generated? 9 985.6 volts. You have to write down volts. 985.6 volts. 985. You got 985? Please do, all of you do. You'll get 5 marks. Easy question. Write down given data, apply the formula, substitute the data. You'll get the answer. 5 marks question. Now you'll go for the second problem. Practice, it is a practice session. You go for the second problem. You'll get a lot of confidence on you. If you do the second problem, you'll get a lot of confidence on you. Please, I will give 1 minute time to complete the first question. Question 1. 1 to 2 minutes. Please complete. You have to practice by yourself. Please don't copy. Practice by yourself. Please don't copy. You have to show the notes. Hello, madam. Get the notes. Have you done? You got the answers? Problem 2. Problem 2. Those who completed problem 1. Those who completed problem 1. Please go for problem 2. It is for 5 marks question. It is for 5 marks question. Final exam only. I'm talking about the final exam. You'll get this kind of questions. Confirm you'll get this kind of. అది పెన్ పెన్ కావాలి సెట్ చేయలేదు సార్ పక్కన చేయి. ఉమ్, గోడ వస్తలేదు నాకు దాంతో వస్తా డైరెక్ట్ గా. రైట్. ఏ వేవ్ కనెక్టెడ్ armature winding, a wave connected armature winding has 19 slots and 44 conductors per slot. A wave, this is one type of design. This is called one type of design. A wave connected armature winding has 19 slots with 44 conductors per slot. If the flux per pole is, if the flux per pole is 0.066 Weber, 0.066 Weber, and the number of poles is 8. Calculate the speed at which generator should run to give 564 volts. Calculate the speed if the armature is lap connected. Complete the question. Completed, all of you completed the question? Right. Now see, this is the armature. How many slots are there? 1, 2, 3, 4, 5, 6, 7, 8, 19 slots are there. How many slots? 19. Assumption only. Okay, 19 slots are there. In each slot, how many conductors are placed? 44. Means in each slot we have 44. 1, 2, 3, 4, 5, 6. And it is winded. All 44 are winding from one slot to other slot. When one slot, how many conductors are there? Totally armature, how many slots are there? 19 slots for the armature. In each slot, how many conductors are placed? 44. So these 44 are winding from one slot to other slot. Like this. This is called a design. Now tell me total conductors in the armature. Slots into conductors. Slots into total conductors for the armature. 19 into 44. So 836 conductors present in the armature. Present in the armature. So this is the given data. What is the first design? Wave connected. A bit, wave connected. B bit, lap connected. See, calculate the speed if the armature is lap connected. Have changed the design. The first design is wave connected. After that, I have changed the design. Next design is lap connected. But what we have to find out? How much speed it is rotating to give 564 volts? In armature, how much voltage is generated? In armature, how much generated? How much? 564. In armature, in conductor, armature is conductor. In armature means conductor. Conductor means copper wire. In copper wire. In this copper wire, how much voltage generated? 564. In the copper wire, how much generated? 560 volts has generated. But what is the speed of the armature to get 564? What is the speed of the armature? What is the speed of the armature to get 564? How much rotation we should rotate to get 564? 564. We have to find out the speed of the armature. We have to find out the speed of the armature. Find out. Given data. Number of poles, 8. Confirm the design is 8. The design is 8. Next one. Total conductors for the armature, 19 into 44. Next one, flux, 0.00 Weber. Next one, EG. What is EG? 564. Wave winding heading, A is equal to 2. Wave winding heading, A bit 2. Write on the formula. EG is equal to P into phi. So we have to find out only N. You have to find out N. Get the answer. To get 564, armature should rotate with how much speed? To get 564, armature should rotate with what speed? You got 53? Yes. So if you rotate the armature 153, okay, then we'll get 564. Then we get 564. You have to rotate 153 with the speed of 153. Then only you'll get 564 in the copper wire. In the copper wire. This is one type of design. If I change the design, Beep it, lab winding, lab connected, lab winding, lab connected, lab winding, lab connected. If I change the design, then what is the speed rotation? Rotation of the armature. Rotation of the armature. So you should not see the board. For the problems, please don't see the board. Practice. Okay, you'll get practice. Then you'll get some doubts. Problem should not be seen. You don't see the mobile phones, whatever it may be. You have to practice by yourself to get the confidence. That's why I'm giving time to you. Practice. Problems should be practiced. Right. This is a confirm question. Please practice. Please practice. This is a confirm question for the final exam. Derivation also is very important for me. How you got EG? Derivation is also very important for me. How you got EG? Right. Okay, we can do it later on. We have to come. We have to go for other problems. Right. Now DC generator is completed. Can you get 10 marks? Yes. The roads are perfect. Yesterday we have discussed about the construction, working principle, EMF equation, and problems. Clear? Now DC motor. Next topic is DC motor. It's very important for me. Why I'm going for DC? You have to understand this DC motor statement because we use in moving iron, moving PMC, measuring instruments, measuring instruments or measurements. PMMC, moving iron, runs on this principle, runs on this principle or working. You have to remember this one. If you want to go for measurements, measuring instruments or measurements, PMMC, moving iron, you have to understand the concept of DC motor. You have to understand the concept of DC motor to get the knowledge of PMMC and moving iron. Right. First, I need a magnet. Yes, magnet. North pole to south pole, main flux. This called, the small one is called conductor. Instead of armature, I have taken small conductor. I cannot draw the armature. I cannot draw the armature. Instead of armature, in armature, what we have? Copper wire. From one slot to other slot. One slot to other. That is called armature conductor, armature winding, or copper wire. Or these are the names given to the armature. So I cannot draw the armature here. I cannot draw the armature. Instead of other one, the small is called armature, called conductor, called made up of copper. Made up of copper. First, I need a magnetic field. Magnetic field I need. First of all, I need a magnetic field, north pole to south pole. It is electromagnet or a permanent magnet? Which one we have taken? Permanent magnet means we get from Earth. Electromagnet means we had made the electromagnet. Take a steel bar, wound a wire, give a supply to the winding, give a current flows to the winding, copper wire. This is called a copper wire. Through the after a few seconds, steel bar becomes a magnet called electromagnet. Practically, we use electromagnet. I told you, never use the natural magnets. Practically, we use the electromagnet. So this called, this north pole, south pole is called electromagnet. I have not done the winding on this one. I have not done the winding on this one. I have not shown the winding. Only north pole to south pole. It is a north pole to south. First condition is I need flux, magnetic field. That is called main flux. That is called. Which magnet have you taken? Natural magnets or electromagnet? Electromagnet, confirm. But here I have not shown the winding. I have not shown the winding on the north pole, south pole. I have not shown the winding on the north pole, south pole. Just it is a electromagnet. Just it is a electromagnet. So north pole to south pole, we got the magnetic field. First one, we should have a magnetic field. First one should have a. Then conductor should place in magnetic field. Then conductor should place in field. Confirm. This is the first diagram. This is the first diagram. Now this conductor does not carry a current. This conductor does not carry a current. This is a diagram which is having electromagnet, north pole to south pole, flux is flowing, called main flux. Flux, what is mean by flux? Magnetic field. What is flux? Magnetic field. Is a technical name. It is a technical name. Flux is a technical name. Flux is nothing but a magnetic field. How you get a magnetic field? If you have a magnets. If you have a magnets, you will get a magnetic field. The magnetic field is flux. Confirm? First diagram should be very confirm. What we should have? We should have first one is magnetic field. First one is magnetic field. What kind of magnet we have taken? Natural magnet or electromagnet? Electromagnet. How to make electromagnet? Take a steel bar, wound a copper wire, give a supply to copper wire, give a supply with help of battery, current flows with the copper wire, current flows with the, after few seconds, steel bar becomes magnet. This is called electromagnet. So I'm taking the electromagnet. I'm taking the electromagnet for DC motor. For DC motor. But yeah, here I have not shown the winding. Here I have not shown the winding on the steel bar. Here I have not shown the winding on the steel bar. Which is the steel bar? This is the steel bar. This is the steel bar. I have not shown the winding on the steel bar. It is electromagnet. It is a electromagnet. In magnetic field, what I have placed? In magnetic field, what I have placed? Conductor. It is nothing but a practical armature. I cannot draw the armature. Instead of armature, I am taking only copper wire called conductor. I am placing in the magnetic field to understand the concept. This is the first question. Clear. Now this conductor should rotate. The final conclusion is the conductor should rotate automatically. This is the final conclusion. What is the final conclusion? What is our target? Conductor should rotate automatically. Automatically rotate. How it's possible? If it rotates means it is a DC motor. If armature rotates means DC motor. Armature is nothing but a conductor. If armature rotates, we got DC motor. We got target finished. Our target to rotate conductor. Our target to rotate conductor called armature. Once it rotates, it is called a DC motor. Once it rotates, it is called a DC motor. That have to explain how it rotates. How it rotates, I have to explain now. How it rotates. Now, first we have to give the statement first, then we'll go for the working principle of DC motor. First, I have to give the statement. Then I will go for the working principle of a DC motor, how it rotates. Working principle of DC motor means how it rotates in the magnetic field. Conductor ela rotate avutundi. Clear? Is first condition. First diagram is finished. Conductor should placed in magnetic field. Conductor does not carry say current. Condition enti? What is the condition? Conductor does not carry say current, just conductor. What is our target? Conductor should rotate automatically. That is called DC motor. That is called DC motor. Right. Now I will go for the statement. I will go for the statement. I go for the statement. Right. Now this conductor should given a supply. The conductor should given a supply with help of batteries. This is the condition. We cannot do anything. Conductor should given a supply with help of battery. Now with help of, if I given a voltage, what will flow? Current will flow through the conductor. Current will flow through the conductor. Confirm? Yes. We should give a supply to the conductor so that current flows to the conductor. So that current flows to the conductor. Now I will make a statement. Now I will make a statement. Now conductor carries a current, correct or not? Because we have given the supply. Because I have given the supply, current flows to the conductor. Current flows to the conductor. Now conductor carries a current or not? Yes. Now conductor carries a current. Why it is carries a current? Because I have given the supply with help of battery. With help of battery. I have given the voltage to the conductor so that current flows to the conductor. Now conductor carries a current. Confirm. The conductor carries a current. Confirm. Whenever a conductor carries a current which is placed in magnetic field. Whenever a conductor carries a current which is placed in magnetic field, then conductor will experience a force, automatic force created. Automatic force has been created on the conductor, conductor will rotate. Conductor will rotate. Finish. This is called statement. This is called our target reached. Huh?
Chargeable.
Hello, 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 hello. Right. Now we are reached our target. Conductor is rotating. This called DC motor. This called, it's clear now? Now we have to make a statement. What is the statement of the DC motor? Whenever a conductor carries current which is placed in magnetic field, conductor will experience a force. Conductor experience a force. Force means rotation. Force means, this is a statement of the DC motor. This is a statement of the DC. Now I want need the definition of motor. Statement is completed. Statement is now motor definition. What is the input given here? Voltage. What is the input given here? Because of voltage, what will flow? Current. Can I say input is electrical? Input is electrical. Because I haven't given the voltage, current flows to the conductor. Is electrical? Yes, it is electrical. What is the output? Rotation. What is the output? Now definition, what is the definition of motor? Which converts electrical to mechanical. Which converts electrical to mechanical. We have given the supply to the conductor so that current flows to the conductor. It is electrical one. Is a electrical. The final target is, it is rotating. The final target is, it is rotating. Then what is the definition of motor? Which converts electrical to mechanical. Which converts electrical to mechanical. So now we go for the definitions. Yes, DC motor. A DC motor is an electrical machine which converts electrical energy into mechanical energy. It's clear now? Right. Now statement. It states that when a current carrying conductor is placed in magnetic field, it experiences a mechanical force. This is called statement of DC motor. This is called statement of DC motor. So definition is completed and statement is completed. Now we have to prove how it is rotating. Now we have to prove how it is rotating is called working principle of a DC motor. Is called working principle of a DC motor. This is for 10 marks question. Explain the working principle of DC motor. Final exam 10 marks question. 10 marks question. So clear? Now the explanation starts. How it rotates. The explanation starts. How it rotates. The 4 diagrams. I need 4 diagrams. Already first diagram is completed. First diagram is completed. Second diagram. This is called second diagram. This is called third diagram. This is called fourth diagram. Finally, we got a force. This is called force. Within 4 diagrams, I will complete the working principle of a DC motor. I will prove how it rotates. I will prove how it rotates with 4 diagrams. With 4 diagrams. Is it clear? Hello? So tell me how many diagrams will complete the working principle? Within how many diagrams will complete the working principle? 4. Right. The second diagram. The second diagram. The conductor is made up of, it is armature. It is a armature. Yesterday we have discussed that how to make a armature. How to make armature. Take a steel bar. Take a steel bar. Yesterday we have discussed armature. Cut into slots. Cut into slots. Then put the winding for one slot to clear. Yesterday we have discussed this one. Conductor is nothing but armature. Conductor is nothing but a armature. Now I have given the voltage here plus minus V. Same thing. Conductor is given a voltage or not? Conductor is given a voltage or not? Yes. Same thing. This is armature plus minus V with help of battery. With help of battery. Now current flows through the winding. current flows through the winding I. See, same thing. This conductor carries a current with help of battery. With help of the same thing I'm explaining here. It is armature. Winding is wound. Give a voltage V with help of battery. Current flows through the winding. Current flows through the winding. Can I say this? It is made up of steel bar? It is made up of steel bar. Can I say after a few seconds the steel bar becomes a magnet? After a few seconds it becomes a armature will becomes a magnet. Armature will becomes a magnet. Take a steel bar, cut into slots, make a winding, give a supply, current flows. After a few seconds, the armature becomes a magnet. Confirm. Now conductor becomes a magnet. Now conductor becomes a magnet. This is the second diagram. This is the second diagram. Clear all of you? How it becomes a magnet? How it becomes a magnet? How conductor or armature becomes a magnet? Conductor or armature becomes a magnet. How? Because it is armature is made up of steel bar. Cut into slots. Give voltage. Current will flow. Then armature becomes a magnet. Same thing. Take a steel bar. Want a supply. Give a voltage. Current will flow. After a few seconds, steel bar becomes same principle armature. Armature is made up of steel bar. Armature is made up of we have given voltage to the steel bar. We have given voltage. Current flows to the winding. After a few seconds, the conductor becomes a magnet. The conductor becomes a magnet. So we got two magnets. One is main flux. This is called a main flux. Electromagnet. Electro. Now this becomes a magnet. We got one more flux around the conductor. This conductor carries a current. Cross. The cross indicates it carries a current. Here no cross. Here cross indicates it is a carries a current. Once it carries a current, this becomes a magnet. Conductor becomes a called armature. We got one more flux called armature flux. Called armature. This is called armature flux, armature magnetic field. This is called armature magnetic field. Now two flux, main flux, armature flux. Main flux, armature flux. We got two fluxes. We got two fluxes. One is called main flux electromagnet. The second one is armature flux. Conductor becomes a magnet. What is the other name for conductor? Armature. What is the other name for conductor? Armature. How to make a armature? Take a steel bar, cut into circle shape, make a slots, put the winding in the one slot to other slot. For this armature, give a battery voltage. Current flows through the winding. After a few seconds, armature becomes a magnet called armature magnetic field. Otherwise, armature flux. Now we got two fluxes, main flux and armature flux. Clear all of you? Second diagram. We got two fluxes. Why we are doing all this? Final target is armature should rotate. What is the final target? Armature should rotate. We have to satisfy DC motor definition. We have to satisfy what is the DC motor definition? Which converts electrical to mechanical. I have to satisfy the definition. For that purpose, I'm explaining this main flux and armature flux. Main flux and armature flux. This is confirm. This is second diagram. In second diagram, we have generated the armature flux. We have generated the armature. Right, clear. This armature flux is rotating in clockwise. It may also rotate in anti-clockwise also. We cannot tell. It may be clockwise. It may be anti-clockwise. To know this one, we have to apply right hand thumb rule. We have to apply right hand thumb rule. If you know this exactly, then I can say it is clockwise or anti-clockwise. Armature flux will rotate clockwise or anti-clockwise. Instead of this one, it is assumption only. We don't know the exact clockwise or anti-clockwise. But to get this one, what rule we have to apply? What rule we have to apply? Right hand thumb rule. to exactly know the direction, clockwise or anti-clockwise. So we are not applying because we need some more data. We need some more data. So we don't require. My assumption is clockwise. My assumption is clockwise armature flux. To get the exactly clockwise anti-clock, which one we have to use? Right hand thumb rule. If you use this one, exactly we get clockwise or anti-clockwise. Now we cannot use that one because in designs we use, but in assumption it is clockwise. Assumption it is clockwise. Clear? Right. Second diagram is completed. Second diagram is completed. Now third diagram. We have to reach fourth diagram. We have to reach fourth. What is the fourth diagram? Armature is rotating. What is the fourth diagram? Right. Now see this. This is the main flux. This is called armature flux. Main flux, armature flux. I have taken 6 lines, main flux. This is the armature flux. Assumption, armature flux, armature flux. Now see the direction clockwise. This is anti-clockwise. These all are clockwise. Observe the diagram very carefully. Very carefully observe the diagram. This flux and this flux are in same direction, left side. Main flux and armature flux. See the direction. Clockwise. This is also main, like this, north pole to south pole. This is main flux. This is armature. Both are in same direction, helping each other. Adding 3 plus 3, 6. We get more flux on the left side. We get more flux on the left side. Here I have taken only 6 lines, but it is not a 6 lines, lakhs of lines. To understand the concept, I have taken only 6 lines and only three. 1, 2, 3. Practically, we have lakhs of lines which cannot be seen. Which cannot be seen. We get lakhs of lines which cannot be seen. To understand the concept, we have taken 6 lines and 3 rotation. 3 rotation, armature flux. Now say that these 3 are in helping each other. We get more flux on the left side. We get more flux on the left side and cancel each other. These two, right side, main flux and are opposite to each other. Opposite to each other. We get very low flux, negligible, very low flux on the right side. Finally, this total flux will apply force on the armature, so though that armature will rotate. So that armature will rotate. The left side flux will apply force on the armature to rotate. Left side of the flux, we get more flux on the left side. We get a weak flux on the right side. Why we got very weak flux on the right side? Opposite each other. Armature flux and the main flux opposite to each other, cancel each other. We get right side very low flux, negligible flux. Left side, more flux. Left side, why we get a more flux? Armature flux, main flux helping each other, adding each other. We get more flux. Once we get a more flux, what will do the flux? Apply force on the armature. Apply force on the, automatically it will apply. Automatically, so that armature will rotate. So that armature will rotate. This is the final conclusion of the working principle of a DC motor. DC motor. What is the fourth diagram? What do you understand by fourth diagram? What is the fourth diagram? What do you understand by fourth diagram? We got more flux on the left side. We got less flux on the right side. Strong flux, weak flux. Strong flux, weak flux. Why we got a strong flux? Armature flux and main flux helping each other, adding each other, we get more flux. Right side, opposite each other. What are the opposition? Armature flux, main flux, both are in opposite direction. We get a weak flux on the right side. But who will apply the force on the armature? Strong flux. Strong flux will apply force on the armature to rotate the armature. To rotate the, in this way, armature will rotate. In this way, armature will rotate. So you have to write down all those things. What we have discussed, we have tried. I have given the formulas. See this one. Once you check, you can check afterwards. So these are the notes. Same style. Okay. These are notes for 10 marks question. The flux produced by the permanent magnet is called length. The flux produced by the current carrying conductor is called armature flux. Same notes. After that, direction. Right. Now, direction of rotation of the motor. Armature is rotating with a force. Correct, correct, confirm. But how much force is required to rotate the armature? It depends upon B, flux density, left side. How much strong it is. How much strong it is, clause flux density. Next one, current. We have given the current or not to the armature? Who has given the current? We have given. With help of battery. With help of more current, more force. Less current, less force. We have given the current to the armature with help of battery. Input electrical. Input electrical. So it depends upon the current. How much current you are giving? Length of the coil. How many conductors you have taken? Copper wire winding from one slot to other. So length. It depends. More length, more force. Less length, less force. So this is the formula generated. Sin theta means angle. How much angle it is rotating? With what angle you are rotating? So this is the formula generated. Next one. Last one. Now finally conductor is rotating. Finally conductor is rotating. The conductor is rotating anti-clockwise. It may be. We cannot tell. So to know the exact direction, whether it is clockwise or anti-clockwise, what you have to apply? Fleming's left-hand rule to get the direction of the armature, whether it is clockwise or anti-clockwise. Final conclusion, armature will rotate. Final conclusion, armature will rotate. Whether it is rotating clockwise or what rule we have to apply? Fleming left-hand rule. Fleming's left. All should be 90 degrees. All should be 90 degrees. 90, 90, 90. From this, we have to know two conditions. What are the two conditions? North pole to south pole, main flux. We are designing the main flux. Who are designing the main flux? Electromagnet. We are designing the electromagnet. Who are designing the electromagnet? We are designing the electromagnet. We should know the north pole to south pole direction. One is this current through the armature. Who is giving the current? We are giving the current. Electrical input. We are giving the current. These two we are giving. Automatically, this is the rotation. Automatically, this is the. You should know the direction of north pole to south pole. You should know the direction of index finger. Shows the direction of the magnetic field. Shows the direction of the. What middle finger shows the current through the armature. Current through the armature. Thumb finger indicates clockwise or anti-clockwise. We will know the clockwise or anti-clockwise. So this for 10 marks question. We have completed the applications. If you want to go for applications, read the applications where we use. We have three types of motors. Remember that. Three designs. Series motor, shunt motor, compound motor. Motor is three designs. You got this question. Give the applications of DC motor. 2 marks question. 1 mark question. That's why I have prepared the notes. How many types of DC motors? What are they? Series, shunt, compound. Just only applications. Only applications. So read it the applications. So the motor is completed. Motor is all the applications for 1 mark question. 10 marks question. What you have to write down? Definition of a motor. Statement, working principle. Then F is equal to B. F is equal to B into I into L into sin theta. Fifth one, Fleming's left-hand rule. Fleming's application for 1 mark question. Application for 1 mark or 2 marks question. To get 10 marks. To get 10 marks, explain the working principle of DC motor. What you will write? Hello. What you will write for 10 marks question? Definition of a motor. Statement of a motor. Working principle of a motor with 4 diagrams. With 4 diagrams. Then F is equal to B into I into L into sin theta. Next one. Fleming's left-hand rule. Fleming's left hand rule. So ఇది మన DC motor completed. Question 10 marks question. 10 marks question is completed. So from machines we have completed DC generator, DC motor. We have completed DC generator, DC motor. Now we'll get the next question is transformer. Transformer problems we'll get. We'll do the problems, important problems. Problems are very important for us. Next question, transformer. We'll get 3 questions. Explain the working principle of transformer. Derive the EMF equation of a transformer. Problems on transformer. Construction of a transformer. For 10 marks question. Transformer 4 questions. Transformer 4 questions. Transformer 4 questions. What is first question? Explain the working principle of transformer. Derive the EMF equation of a transformer. Problems on EMF equation of a transformer. Construction of a transformer. Construction of a transformer. We'll get this kind of questions. We'll get this kind of questions. Hello, madam. Tell me 4 questions. Explain the working principle of transformer. Second question. Derive the EMF equation of a transformer. Problems on EMF equation of a transformer. Construction of a transformer. These are the questions from machines. Unit 2. Unit 2. If you read these questions, confirm you'll get all the previous question paper also same questions. Not to worry. Right now, working principle. Just 5 minutes we have completed the working principle. Then we'll go for problems. Now we have 2 windings. Primary winding, secondary winding. Take a steel bar, again steel bar. Take a steel bar, cut into this shape. This shape lo cut cheskondi. Take a steel bar, cut into this shape. Right? Take a steel bar. Same diagram. We'll get this diagram only. Same diagram. Take a steel bar, cut into this shape. After that, take a copper wires. Take a copper wires. Wound the copper wire. Wound the copper wire. Wind the copper wire. Take second copper wire. Take second copper wire. Again, wind the copper wire. To make a transformer. To make a transformer. Take a steel bar, cut into square shape. Take copper wire, wind on the left side, winding on the right side. Now this is called a simple transformer. Simple transformer. Now we have to give the supply. Now we have to give the supply. If you give left side or right side, you can give any one. If you give, wherever you give a supply, it is called a primary. It is called a, if you give right side, right becomes primary. If you give left side, primary. Wherever you give a supply, we have to give the supply. We have to give the AC supply. We have to give the, if you give left side, left becomes primary winding. If you give right side, right becomes primary. The other will be second. The other will be second. Clear all of you? You can give any left side, right side. We have to give the supply. Remember that. We have to give the AC supply, not DC supply. We have to give the AC supply. Supply voltage V. We should give V. We can give anywhere. We can give left side or right side. Anywhere. It's not confirmed that left side, right side. If you give left side, left become primary. If you give right side, right becomes primary. The other will be second. The other will be secondary. Right? Confirm? Clear? Right. Listen, all of you. Now I am giving left side. Now I am giving left side. Left side voltage is given. Left side voltage is given. What kind of voltage? AC voltage. AC voltage given called V1. Called, this is the voltage given. V1 on the left side. This becomes primary winding. This becomes secondary winding. On secondary winding, we have to apply the load. We have to apply the load. Primary, we have given the supply, AC supply, V1, confirm. We have to given the, V1 has given supply, AC supply, not DC supply, AC supply. Why I am doing all these things? Question 1. Because the secondary side is a load. The load may be individual house, apartments, or any bulb. The bulb needs the voltage. The bulb needs the, it may be 230, it may be 20 volts, it may be 10 volts, whatever may be. The bulb needs AC. 10 volts, 20 volts, 100 volts, 1000 volts. If it is a bulb. If it is an independent house, we need 230 for this room, independent house. This is the load. This is the load. Apartment. Apartment needs the voltage. Apartments. That is called load. Finally, our target is the apartment needs voltage. The bulb needs voltage. This room needs voltage. For that purpose, the computer needs voltage. The computer, if you open the inside, we have small transformer. We have transformer. In the computer will run on 12 volts only. The computer will run on 12 volts only. The computer run with 12 volts. When we switch on the supply, we'll get 230. We'll get, when you apply the CPU to the switchboard, what is the voltage of the switchboard? 230. What is the voltage switchboard? 230. Whenever you switch on, how much voltage should go to the computer? 230. But computer needs, how is it possible? Inside computer, we have a transformer. Inside computer, we have a, the computer will change from 230 to 12 volts. Computer is a load. Computer is a load. Computer is a load. Computer needs how much voltage? 12 volts. But our switchboard is 230. When we switch on the CPU, how much voltage should enter? 230. But inside what we have? Transformer will convert 230 to 12. Finish. Completed. We need transformer or not? This application. This is called, where we use the transformer. Where we use the transformer. This is application. Right. Now go for second application. This is the first application. Computer is the first application. Now second application. Adapter. Charger. Charger, adapter, mobile phone. Mobile phone needs 3.7 DC volts. The mobile phone needs how much voltage? Full charging. Full charging, what is the voltage? 3.7 DC. Then how is it possible? We have 230. When put the adapter in the switchboard, what is the input? 230. Then I have to design I should design a rectified design. The adapter is a rectified design. The adapter is called charger. Rectified design తయారు చేయాలి. ఆ రెక్టిఫైర్ ఏముంది అంటే కనుక, వాట్ ఈస్ దేర్ ఇన్ ద రెక్టిఫైర్? ట్రాన్స్ఫార్మర్ which converts 230 to 6 volts AC. 230 to 6 volts AC. 6 volts is converted to 3.7 DC with help of diodes. With help of diodes. Rectifier, we have two common, transformer and diodes. In rectifier, what we have? Transformer and diode. First, transformer will convert 230 to 6 volts AC. 230 to 6 volts AC. Then AC is converted to 3 points DC with help of diodes. That is called rectifier. In rectifier, we have two things. One is called transformer, the other is called diodes. With help of these two, will convert 3.7 DC, which is given to mobile phone. Which is given to mobile phone. This is the second application. Is it important or not? Transformer is very important for me. Transformer is very, for example, forget these two things application. Rectifier application, one is called computer application. Forget this one. Now this room needs 230 volts. Needs AC. Then I need a transformer. The load is called apartments, individual house, rectifier. Load may be a computer. Load may be a. I need that voltage. How I need V2. I need V2 volt across the load. It may be 20 volts, it may be 230 volts, it may be 6 volts, it may be whatever it may be. We have to use for computers, we have to use for rectifiers, we have to use for individual house, we have to use for apartments, use for substations, whatever it may be, I need V2. I need, for V2, I need a transformer. To get the value of V2, to get the value of V2, I should make a design of transformer. I should make a design of transformer. This is called a design of transformer. What is our target? V2 across the load. Across the, what is our target of transformer? Voltage across the load. Voltage across the load. V2, I need V2. For that purpose, I should have a transformer. For that purpose, I should have a transformer. How to make a transformer? Take a steel bar. Okay, cut into square shape. Wound a wire on the left side and right side. Now give the supply anywhere, left side or right side. Wherever you give a supply, it is called a, the other will be secondary. Apply load to the secondary. Apply load to the secondary. The bulb, the load, computer need a 6 volts, 12 volts transformer. V2 is equal to 12 volts. V2 is equal to 12 volts. What is load here? Computer. Assumption that computer. CPU. Clear? Now, how I will get V2? That is called working principle of a transformer. That is called transformer. How I will get V2? How I will get V2? So, for that purpose, I will explain the how we get V2. Right. First thing, we should give the supply. This is called a switchboard. Switchboard. Apply one terminal, second terminal to the board. We have switchboard, no? Plug, wherever it may be. Apply, switch on. Switch on the supply. Now V1 will enter into the voltage. Because of voltage, current will flow. What is the current waveform? This is the current waveform I1. This is called I1. This is called V1. Because of V1, we got I1. Because of V1, we got I1. Now I1 will enter into the coil. Enter into the copper wire. Whenever it enter into the copper wire, can I take it as steel bar? This is made up of steel bar. Wounded. Can I make this steel bar becomes a magnet? This steel bar becomes a. Now can I get magnetic field? Can I get a flux? This is called a flux. The practical diagram is, this is the practical diagram. This is the practical case. We'll get here. This is the flux, we got it. This is the flux around the primary winding. This is the practical case. But I'm not showing. This is the line I'm showing it. This is a simple line. This is a simple line we have shown. This is the practical case. Around the coil, we got a flux. Around the coil, we got a flux. Magnetic field, we got it. We got it. Magnetic field. How we got a magnetic field? First, V1 should be applied. First, V1 should be applied. Because of V1, what will flow? I1. I1 enters into the copper wire. I1 enters into the. After few seconds, we got a magnetic field. around the coil. Around the, it is shown by single line. It is shown by, it is a practical case. It is a practical case. It is a practical case. రావట్లేదు. Okay, I don't want to waste the time. కూర్చోండి. Single line diagram. Flux phi m. Flux phi m. Right. Because of V1, what will flow? I1. I1 will enter into the winding, primary winding. Enter into the primary winding. After entering into the primary winding, what we got? Flux around the coil. Around the coil. Now, whenever a flux links with the coil, whenever a flux links with the coil, EMF is induced in the coil. EMF is induced in the coil. We got a coil here. We got induced EMF in the coil. Faraday's first law. Faraday's, whenever a flux links with the coil, we got a EMF called E1, self-induced EMF. Self-induced. We got one more voltage across the coil. That is called E1, self-induced EMF. Why we got this one? Because of Faraday's first law. Whenever a flux links with the coil, whenever a flux links with the coil, EMF is induced in the coil. We got a voltage. We got a voltage. We got a voltage. How you got even? How you got even? Because of flux. Because of, how you got flux? Because of current. How you got current? Because of voltage. Clear? How you got even? Faraday's statement. How you got even? Faraday's statement. What is the statement? Whenever a flux, change in flux, whenever a change in flux links with the coil, coil means primary winding. Coil means primary winding. Whenever a change in flux, which is a change in flux? This is called change in flux. This is called change in flux. This is called flux. This is called voltage. This is called current. See, V1, I1 flux. V1, I1 flux. Clear all of you? Right. How we got even? How you got even? Because of Faraday's first law. Because of, what is Faraday's first law? Whenever a change in flux links with the coil, what is coil? Primary winding. Whenever a change in flux links with the coil, EMF is induced in the coil, called E1, called self-induced EMF. Automatic, we got it. Automatic వచ్చేసి. We got automatic even. Because of Faraday's first law. Because of, how you got flux? Current. Current should enter into the coil. How you got current? Because of voltage. So we have to give the supply to get even. To get even. We have to give the supply to get even across the primary winding. Across the, right. Finish. Completed. We got self-induced EMF. Now we have to get E2. Now we have to get E2. Now we have to get this one. E2. After that, V2. First E1, E2, V2. Our target is V2. Our target is V2. First we have to get E1, then E2, then V2 across the load. Across the, confirm. Now the same flux links with the coil 2. The same flux links with the, again Faraday's first law. Again Faraday's first law. What is the first law? Change in flux links with the coil 2. Change in flux links with secondary means this is called change in flux. This called change in flux. This called change in flux. This called change in flux. The change in flux links with coil 2, N2. Coil 2, N2. What is coil 2? Secondary winding. What is coil 2? Secondary winding called N2. Called N2. Whenever a change in flux links with the coil 2, EMF is induced in the coil 2 called E2. Called mutual induced EMF. Called mutual induced EMF. How you got E2? Because Faraday's first law. How you got E2? Faraday's first law. What is Faraday's first law? Whenever a change in flux links with coil 2, what is coil 2? Secondary winding, N2. Secondary winding called mutual induced EMF. Mutual induced EMF. Like this, we got it. Self-induced EMF, mutual induced EMF. Self-induced EMF, mutual induced EMF. We got I1, we got E2, then we get V2. Then we get V2. Our target is V2. Our target is V2. Clear? Right. How you got E2? Faraday's first law. What is the statement? Whenever a change in flux, whenever a change in flux links with the coil, EMF is induced in the coil called E2. Called E2. How we got E2? How we got E2? We need flux. We need. How you got flux? From primary winding. From primary winding నుంచి తీసుకున్నా. I've taken from primary winding. The flux, first flux ఎక్కడ ప్రొడ్యూస్ అయింది? ప్రైమరీ దగ్గర. అక్కడి నుంచి తీసుకున్నా. I've taken from that. Flux. Link cover. Clear? Next one. How you got even? Statement. How you got even? Faraday's first law. Faraday's? What is the first law? Whenever change in flux links with coil 1, EMF is induced in the coil 1. Coil 1 means primary winding. E1. What is the E1 called? Self-induced EMF. Self-induced EMF. Clear? We got even. To get even, who is the responsibility? Flux. Who is the responsibility? Flux. Flux to get flux, who is the responsibility? I1. To get I1, who is the responsibility? V1. V1. So this is the link. So we got E2. We got E2. Now see this one. This is made up of copper wire. This is made up of copper wire. It is made up of. In this copper, we have electrons. But they are not moving. They are moving in random direction. They are moving in. We cannot use that random direction. We cannot use. We need a uniform direction. Uniform. To get uniform, we should have voltage in this one. We should have. We got voltage or not? E2. This is the copper wire. We have electrons in this one. Electrons not moving. Electrons are not moving. It is waiting for E2. It is waiting for E2. E2 కోసం వెయిట్ చేస్తుంది అది. Electrons, current. It is waiting for, electrons are waiting for whom? E2. E2 should be induced in the coil 2. E2 should be induced in the coil 2. It is waiting. Electrons are waiting. When we got E2, electrons will run. Electrons will run in this copper wire. In this copper, what we have? Electrons. But electrons are not moving. Electrons are not moving. To move the electrons, what should have? E2. E2. Once you get E2, the electrons will run. That is called I2. That is called I2. Now load. The computer is having the load RL. It is RL. I2 into RL gives you V2. I2 into RL gives you V2. The computer should have 12 volts. The computer should have 12 volts. The computer is having load RL. I2 into RL gives you V2 across the load. across the load. Finally, we have reached the target or not? Finally, we have reached the target. This is the working principle of a transformer. This is called working principle of a transformer. Once again, to get V2, I need I2. To get V2, I need I2. To get I2, I need E2. To get E2, this flux should link with the coil. This flux links with the coil. Faraday's first law. Whenever a flux links with the coil 2, EMF is induced in the coil 2 called self mutual induced EMF. Mutual induced EMF. To get E2, I need E1. E2 రాయడానికి కారణం ఎవరు? E1. E1. To get E1, flux is the responsibility. To get flux, I1. To get I1, V1. This is the link to get V2. This is the link to get V2. Final target is we should get across the load V2. That is final target. It is coming from V1. It is coming from V1. Because of V1, I got I1. Because of I1, I got flux. Because of flux, I got E1. Even because of E1, I got E2. Because of E2, I got I2. Because of I2, I got V2. This is the chain process. It is a chain process. This is called working principle of a transformer. This is called a working principle of a transformer. Clear, all of you? We will write the question. The same style. I'll give only eight points we have. The notes is 8 point to 9 point, not more than that. 8 point to 9 point, draw the diagram. You'll get 5 marks. 8 point to 9 points. Draw this diagram. How many marks will get? 5 marks. 5 to 10 marks, depending upon the question paper. Depending upon the question paper. Clear? Second question. Derive the EMF equation of a transformer. Derive the EMF equation of a transformer. Now, I need this value. How much we have generated? Whether 200 volts, 400 volts, 100 volts, 220 volts. I need this value. That is called derive the EMF equation of a transformer. What is E2 value? Again, V2 value we should have. 200 volts, 100 volts, 300 volts, we should have. So it depends upon some terms. Even depends upon terms to give the value. E2 depends upon some terms to give the value. To give the value. What is that value? Same EG is equal to phi into P into Z. Same thing. We have a derivation. We have a derivation. Same thing. The equation E1 is equal to 4.44 F into N1 into phi M. This is the equation we have to derive to get some value. 100 volts, 200 volts. It depends upon the frequency. It depends upon the AC. AC means frequency. AC means it depends on the number of turns. N1. More turns, more even. Less turns, less even. Phi M, maximum flux. This is called phi M. This is the formula generated called EMF equation of a transformer. What is the formula? E1 is equal to 4.44 into F frequency into number of turns. N1 into phi M maximum flux. Volts. Volts. Voltage means volts. We have to derive. We have to derive. We have to derive. What is E2? Same thing. 4.44 into F into N2. N1 plus N2. Phi M. Volts. So these two we have to derive now for 5 marks question. Derive the EMF equation of transformer. We have to derive. Then we have to do problems on this one. Then we have to do problems in this one. Right? What is the derivation? What is the derivation of the target? Derivation of what we have to derive? What we have to derive? E1 is equal to 4.44 into F into N1 into phi M volts. E2 is equal to 4.44 into F into N2 into phi M. These two we have to derive now. That is called derive the EMF equation of a transformer for 5 marks question. So this is for explain the working principle of a transformer. Explain the working principle of a, draw this diagram. How many points? How many points I have given? 7, 8, 9, 10 points have we given. 10 points we have explained with 10 points. Working principle of a transformer. Working principle of a transformer. Next question. EMF equation of a transformer. EMF equation of a transformer. First, we should have an equation, flux equation. This is called a flux equation. This is called a flux equation. Phi is equal to phi m sin omega t. Draw this diagram. Draw this diagram to get 5 marks question or 7 marks question. 5 marks question or 7 marks question. Phi is equal to phi m sin omega t. You have to remember this equation. What is V? V1. V is equal to Vm sin omega t. I is equal to Im sin omega t. Then we get flux. Phi is equal to phi m sin omega t. V1 and T. What is V1? Vm sin omega t. What is I1? Im sin omega t. Then what is phi m? Phi m sin omega t. What is V? Vm sin omega t. What is I? Im sin omega t. Then what is flux? Phi m sin omega t. So we have to remember this equation. Phi m sin omega t. Next, what is the formula we required? Second law. This is called second law. What is second law? Formula. Faraday's second law. N1 into d phi by dt minus N1 into d phi. Second law. First law, what is first law? Whenever a conductor links with the flux, EMF is induced in the conductor. EMF is induced in the conductor. This is the first law. What is the second law? Formula. What is the second law? Formula. Every second is the voltage inducing. Every second. Voltage induced in the primary winding. Voltage induced in the every second. Not average. Every second it is inducing. This is called E1 is equal to minus N1 into d phi by dt. What is phi? Phi m sin omega t. Now do the derivation. Then we'll get what is omega? 2 pi f. What is omega? 2 pi f. So we got this one. Now convert cos should be converted into sine. Because our discussion is sine wave. Our discussion is sine wave. Convert cos to sine. Convert cos to sine. What is cos omega t is equal to sine of minus cos omega t is equal to sine of omega t minus 90. Minus cos omega t is equal to sine omega t minus 90. This is called E1. Every second, this is the voltage generated. This is the voltage generated. Mali cheptunna. Again, I am telling. What is the formula we required? First, what is the equation we required? Phi is equal to phi m sin omega t. Confirm. First equation, y is equal to phi m sin omega t. Second one, formula. Which formula? Faraday's second law. Faraday's. What is the formula? E is equal to minus N1 into d phi by dt. Faraday's second law. Clear? First one, what required first one to derive the equation? First one, phi is equal to phi m sin omega t. Second one, Faraday's second law. What is the formula? Minus N1 into d phi by dt. Now what is phi? Phi m sin omega t. Now do the derivation. We get what is omega? 2 pi f. 2 pi. Now convert cos to, why we are converting? Because our discussion is sine wave. Our discussion is sine wave. So convert into sine. Sine minus cos omega t gives the result sine omega t minus 90. Now I want to convert small e1 to maximum m1. Small e, capital E. I want to get maximum voltage. I want to get this every second. This is every second it is inducing in the primary winding. Every second it is inducing in the primary winding. But I want it 90 degrees. But I want it 90 degrees. At 90 degrees, this is called E max. దిస్ కాల్డ్ ఈ వన్ ఇది. ఇక్కడ వోల్టేజ్ ఎంత అని అడుగుతున్నా. ఇదంతా ఈ వన్ at 10 degrees, E2 20 degrees. This called E1. Every second E1 is generating. Every second 10 degrees E1, 20 degrees E1. Every second this is the voltage generated. This is the voltage. This is called instantaneous value. This is called every second this is the voltage generated in the primary winding. Generated in the primary winding. Now I want to convert it to maximum. 90 degrees we got a maximum voltage. At what degrees we got maximum? 90 degrees. See the diagram, maximum. To get this one, we have to satisfy the equation. E1 will become maximum when sine omega t minus 90 is equal to 1. Then this become 1. Then we get E1 becomes E max 1. 2 pi f n1 into phi f. Now I want to convert into RMS values. Now I want to convert into AC means RMS values. Remember that. AC means RMS values. We have to convert. That is confirm. We have to confirm. To confirm RMS value, dividing throughout by root 2. Dividing throughout by root 2. What is E max by root 2? This is called ERMS. Is called ERMS. ERMS 1. Dividing throughout by root 2. Dividing throughout by root 2. So, what is, you have studied ERMS equal to VM by root 2? Have you studied unit 2, unit 1 AC circuits? VRMS is equal to VM by root 2. Unit 1 AC circuits formula. Unit 1 AC circuit formula. VRMS is equal to VM by root 2. Same thing. VM by root 2. ERMS 1. So is equal to 2 pi by root 2. 4.44. 2 pi by root 2. 4.44. F is equal to N1 into 5. This is called equation. This is called equation. Once again, I want to explain clearly from first onwards. Right. First equation, phi is equal to phi m sin omega t. Draw the diagram. Same working principle diagram. After apply the formula. What is the formula? Faraday's second law. Make derivation. Derive. What is omega? 2 pi ff minus cos omega t. What is minus cos omega t? Sin omega t minus 1. I want to reach maximum EM1. When it will reach 90 degrees. So E1 will become maximum when sin omega t minus 90 is equal to 1. Substituting this one, we get E max 1 is equal to 2 pi f n1. Now I want to convert into RMS values. Now I want to convert into dividing throughout by root 2. Dividing throughout by root 2. Then ERMS1. This is called ERMS1. What is the formula? VRMS is equal to VM by root 2. Unit 2 AC circuits. Unit 1 AC circuits. We have the formula. So this is called ERMS1. Simply called as E1. E1 అంటేనే ERMS. ఎప్పుడైతే ఏసీలో వోల్టేజ్ అంటే అది ఏంటి? RMS. If I talk voltage in AC, what is that it means? RMS. Never mention VRMS. Simply called as E1. It is AC. AC means RMS. AC means, so this is the voltage generated. Similarly, E2. Don't derive. Similarly, E2. Similarly, E2. Clear? Right. That's good. 2 minutes rest. Then we'll go for problems. We'll go for problems. ఒక 2 minutes rest ఇస్తుంది అంతే. 2 minutes rest ఇచ్చి this continue చేస్తాం. బాబు ఎవరైనా వెళ్ళండి. హలో. Okay, right? So these all are questions coming for final exam. I have prepared in such a way that I have seen the previous question papers, I have seen the syllabus, then I have prepared the notes. Now we have to go for two, three formulas to solve the problems. To solve the problems, we have these are the formulas. The first formula is voltage transformer ratio K. Voltage transformer ratio K formula. How you got output by input? Secondary winding by primary winding. Secondary winding by primary winding. Output by input. What is output? E2. What is the input? E1. Output by E1 gives you the formula. If you do this one, all will cancel. Frequency will cancel. Phi m will get cancelled. Last N2, N1 is remained. What is E2? 4.44 F into N1 into phi m by 4.44 F into phi m into N2. 4.44 will cancel. FF cancel. Phi m will cancel. Last is N2 by N1. Output by input. E2 by E1. E2 by E1. We got this formula. Next formula. Ideal transformer. Ideal transformer means the transformer does not have a resistance. If there is no resistance, no voltage drop. Assumption only. Impossible case. Assumption only. Impossible case. Whatever you take, you should have a resistance. But my assumption is we don't have a resistance. Assumption only. It is called a perfect transformer. It is called a means as there is no voltage drop in the winding. Impossible case. We should have a voltage drop. We should have a voltage drop for transformer. It's called a practical transformer. It is called a practical transformer. But it is a ideal transformer. Means perfect transformer. Means perfect transformer. As there is no voltage drop in the winding. As there is no voltage drop in the winding, the final formula, remember this final formula. N2 by N1, E2 by E1 is equal to V2 by V1 is equal to I1 by I2. Remember this formula. Have done a mistake. We should not write this formula here. Okay, please make it correction. Please make it correction. It is a mistake. While printing mistake it is. We should not write this one. It's a printing mistake. We should write V1 is equal to E1. V2 is equal to E2. V1 is equal to E1. V2 is equal to E2. This is a printing mistake. We should not write this one. V1 is equal to E1. V2 is equal to E2. Clear? If from this we got a new formula, output by input, V2 by V1 is equal to E2 by E1. This is a standard formula. One more formula. As there is no voltage drop in the winding, V1 is equal to E1, V2 is equal to E2. V2 by V1 is equal to E2 by E1. This is a standard formula. Last formula. There is no losses. Input power is equal to output power. Input power is equal to output power. Last formula. V1 I1 input power. Voltage into current gives you input power. Output power V2 into I2. So V1 I1 is equal to V2 I2. Therefore, V2 by I1 is equal to I1 by I2. If you write this one, this is the standard formula for all mixed formula. All mixing formula is one. N2 by N1 is equal to E2 by E1 is equal to V2 by V1 is equal to I1 by I2. These are standard formulas for transformer. Now tell me the formulas. First formula, primary winding. E1 is equal to 4.44 F into N1 into 5M. E2 is equal to secondary winding mutual induced EMF. Mutual induced EMF E2 is equal to 4.44 F into N2 into 5M volts. I pin. Clear. Next formula. Voltage transformer ratio K is equal to E2 by E1 is equal to N2 by N1. N2 by next. Ideal transformer. What is called? Ideal transformer. Ideal. What is the first condition? No voltage drop. What is the first condition? No voltage drop. No voltage drop is V1 is equal to E1, V2 is equal to E2. V1 is equal to E1, V2 is equal to E2. No ideal transformer, perfect transformer. We don't have a perfect transformer, we all have practical transformer. We have a in practical transformer, we have a voltage drops. We have a voltage drops. It is ideal transformer, perfect transformer, we don't have a losses. We don't have a losses. Therefore, V1 is equal to E1, V2 is equal to E2. B bit, input power is equal to output power. When we get this assumption, no power losses. No, then input power is equal to output power. What is input power? V1 I1 is equal to output power V2 I2. We get new formula. What is the new formula? V2 by 1 is equal to I1 by I2. Now make it combination formula. N2 by N1 is equal to V2 by V1 is equal to E2 by E1 is equal to I1 by I2. This is standard formula. If you know this all these formulas, then you can do the problem on transformer for 5 marks or 10 marks question final exam. Otherwise, you cannot do the problem. Even if you get, you cannot attempt the problem. You cannot attempt the problem. So the transformer will be completed. Almost transformer will be completed. Right. We'll do the problem on this one. Right on. A 44 kVA kilovolt ampere. A 44 kVA 44 K means 1000 volt ampere. A 44 kVA, K means 1000 volt ampere. Transformer always rated in volt ampere. Transformer always rated in volt ampere. One more question. One more question. Transformer always rated in volt ampere. VA. VA. 1000 by 415 volts. 1000 by 415 volts. 50 Hz single phase transformer has 88 turns on the primary. 88 turns on the primary. Find first one. Number of turns on the secondary. This is one type of design. This is one type of design. Find number of turns on the secondary. Second one. The full load and the full load primary to find out. The full load primary and secondary currents. I1, I2 we have to find out. And the maximum flux of the value of the flux. 5M. 5M. We have to find out 5M. Please note on the question. Practice. You got this question in the previous question papers. These are all of the previous question papers. Look at design. E design key. What is V1? V1 is equal to E1. V1 is equal to, it is a ideal transformer. The assumption is ideal transformer, not it is a practical transformer. It is a assumption it is ideal transformer. No voltage drop, no power losses. No voltage drop, No power losses. Therefore, this called V1 I1 primary side. This called V2 I2 secondary side. V1 is equal to E1 is equal to 1000. V1 is equal to E1 is equal to 1000. V2 is equal to E2 is equal to 415. For 88 turns, how much voltage we got it? 1000. For 88 turns, how much voltage we got it? For 415, how much turns we required? N2 we required. For 1000 volts, how many turns required? 88. For 415, we have to find out. For 415 voltage, can I say it is step down transformer? Step down 1000 into 415. Primary winding to secondary winding. 1000 to 450. What kind of transformer it is? Step down transformer. I told you 230 to 12 volts. Computer needs 12 volts. So what kind of transformer we need for the computer? Step down transformer. Step down transformer. Depending upon this rating, we can say that. Right. Given data. Write down given data. Given data. Given data. Yes. S is called, remember, S is called apparent power. S is called apparent power. S is called apparent. How you got S means unit 1 AC circuits. How you got S? Unit 1 AC circuits. From there I got S. Apparent power. S. APPARENT. APPARENT. Apparent power. S is called apparent power. 44 kVA. Rating of the transformer. This is called rating of the transformer, always in apparent power. Always in apparent power. The rating of the transformer is done in apparent power. APPARENT. Yes, it is indicated by yes. S is equal to 44 kVA. 1000. K means 1000. Next. V1 E1 is equal to how much? 1000. V2 8 is equal to how much? Frequency? N1. Right. Now tell me which formula A bit. What is A bit? N2 call. What is A bit? N2. Heading A is equal to number of turns on the secondary. A bit. After writing given data, A bit. Number of turns on the secondary N2. Number of secondary turns N2. Number of secondary turns N2. So what formula you will use depending upon the formulas? Which formula is easy for you? N2 by N1 is equal to E2 by E1. So you select the formulas. I have given the formulas to you. You select the easiest formula depending upon the data. Depending upon the data, you select the formulas. You select the formulas. So what is the answer? N2 generators required. N2, how many turns required to get 415 volts? How many turns required to get 415 volts? 36.52 required. Number of turns should be turned to get 415 volts. To get 415 volts on the secondary. On the secondary. Next. Next, B bit. What is B bit? I1, I2. B bit. What is B bit? I have not mentioned this one. I have not mentioned my notes. Go for B bit. Go for B bit. What is B bit? Primary and secondary currents. I1, I2. I1, I2. I1, I2. Second B bit. This is called B bit. The full load primary and secondary currents. The full load primary and secondary currents. B bit. B bit. S is equal to, this is the formula, remember, V into I. This is the standard formula. S is equal to V into I. S is equal to standard formula, unit 1 AC circuit apparent power. Unit 1 AC circuit apparent power. Yes, this is standard formula. Now, S is equal to, in primary side, V1 into I1. Secondary side, S is equal to V2 into. What is this? 44,000. What is this? 44,000. Kilo means 1,000. 44,000 is equal to V1. What is V1? What is V1? 1,000. Can you get I1? Find out I1. Find out I1. Next, what is this? 44,000 is equal to what is V2? 450. Get I2. Get? Write down the formula. Please, B bit formula. B bit formula. S is equal to VI. S is equal to VI. B bit. B bit primary and secondary currents. B bit primary and secondary currents. Formula. Make it formula. S is equal to VI. S is equal to. Where you got this formula? Unit 1 AC circuits apparent power formula. S is equal to VI. Now primary side S is equal to V1 I1. S is equal to V1 primary side. Secondary side S is equal to V2 I2. V2 get I1 I2. Get I1 I2. B bit. B bit S is equal to VI formula. S is equal to V1 I1 primary side. S is equal to V2 I2 secondary side. Now substitute the values. We get I1 I2. We get I1 I2. Rating of a transformer is done in apparent power. The answer is, it is designated by S. It is designated by S. S is equal to VI. S is equal to VI. Remember this formula. How you got this formula? Unit 1 AC circuit apparent power. This is B bit. Next, phi m. Find out C bit. Phi m. Find out phi m. What is the formula? E1 is equal to 4.44 F into N1 into phi m. You know E1? You know F? You know N1? Find out phi m. C bit. C bit. Third one. Maximum value of the flux. Maximum value of the flux phi m. 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 Formula చెప్తా. రాసే అందులో maximum value of the flux phi m. Formula E1 is equal to 4.44 F into phi m into N1. 4.44 into F into N1 into phi m. ఇది ఫార్ములా. సేవ్ ఇట్. లాస్ట్ వన్. N1 ఎంత? N1 88 tons. N1 88 tons. Primary side. How many tons primary side? 88. F, what is F? 50. What is E1? 1000. Can you get phi m? Weber. Weber. Units Weber. Units Weber. So A, B, C completed. Number of turns on the secondary. Primary, secondary currents I1, I2. Maximum value of the flux phi m. Maximum of the flux phi m. అయిపోయిందా? Completed. Right. What are the formulas? ట్రాన్స్ఫార్మర్ ఫార్ములాస్ అన్ని ఫస్ట్ నుంచి చెప్పు. ట్రాన్స్ఫార్మర్ ఫార్ములాస్. ప్రైమరీ సైడ్ E1 is equal to 4.44 F into N1 into 5M volts. E1 is known as RMS. E1 is known as, every time I won't mention RMS, even in AC. Ante. What is E2 formula? On secondary side, 4.44 F into N2 into 5M volts. E2 is called mutual induced EMF in RMS. In RMS. Ante finish. Clear? Voltage transformer ratio K formula. E2 by E1 is equal to N2 by N1. E2 by E1 is equal to voltage transformation ratio K. అయిపోయింది. తర్వాత ఐడియల్ ట్రాన్స్ఫార్మర్ ఏ బిట్ బి బిట్. వాట్ ఇస్ ఏ బిట్? నో వోల్టేజ్ డ్రాప్. నో V1 is equal to E1 and V2 is equal to E2. Impossible case, but it is an ideal transformer. It is not a practical transformer. It is a assumption that no voltage drop. B bit, no power losses. No, impossible case. It is not practical transformer. We have a losses. Practical transformer we have a losses. It is impossible case. Ideal transformer is impossible case. Input power is equal to output power. V1 I1 is equal to V2 I2. We get a new formula. What is that formula? V2 by V1 is equal to I1 by I2. So these are the formulas you have to remember to do the problem. To do the problem. Otherwise, you won't get the marks. The last problem, so the transformer will be completed. Write down. A single phase transformer. A single phase transformer has 660 turns. A single phase transformer has 660 turns on the primary and 92 turns on the secondary. A single phase transformer has 660 turns on the primary and 92 turns on the secondary. If the primary is connected to 3600 volt supply, calculate the secondary voltage. Calculate the secondary voltage. If the secondary current is primary current, I think you got this question in the previous question paper. काफी formulas. If you get formulas, you'll get marks. You should remember the formulas. Right, given data. How many turns for the primary? 660 turns. Primary turns. Primary turns, N1 is equal to N2 secondary turns, 92. V1 is equal to E1 is equal to how many voltage? Primary side. Primary side. 3600. What is I2 secondary current flowing? Find out first one. What is the first formula used? N2 by N1 is equal to, we get V2. We get V2. Very simple problem. This is for 5 marks question for the previous question paper. Kakinada University. We have to check చేసుకోండి ఒకసారి. N2 by N1 is equal to V2 by V1. Get V2. Practice. Make practice. Please make practice. Okay, right. You got confidence on you. Will you do transformer? So these are the problems you will get on the transformer. So that we have completed DC generator, DC motor, transformer. Three we have completed. Right now, you'll go for superposition theorem. Superposition theorem. Superposition theorem. Problem 1. Write the formula. Question. Find the current through 4 ohm resistor by using superposition theorem. Find the current through 4 ohm resistor by using superposition theorem. By using superposition theorem. Draw the diagram. Find the current through 4 ohm resistor by using superposition theorem. 20 volts, 5 amperes, 6 ohms, 8 ohms, 4 ohms. Draw the diagram. Right. Listen. Please, all of you listen though. Right. Operate with voltage source that is 20 volts and non-operative current source that is 5 amperes. That is, see, step 1, run with only one source. Run with, the other will be non-operative. The other will be up. If it is non-operative, whenever you say it is non-operative, the resistance for open circuit is infinity. The resistance for current source is infinity. Whenever you say it is non-operative, the resistance for current source is infinity open circuit. Remember this one. Whenever you say non-operative, then the resistance for called internal resistance for current source is, what is the answer? R is equal to infinity open circuit. R is equal to infinity open circuit. This is the, you have to remember again. What is the internal resistance for current? What is the internal resistance for current source? What is the answer? R is equal to infinity open circuit. R is equal to infinity open circuit. If it is the internal resistor voltage source, it is not a current source. Now it is a voltage source. What is the answer? R is equal to 0, short circuit. R is equal to 0. If you remember these two, then you can solve the problem. You can solve the problem. You have to remember two things. Whenever you say it is a non-operative, the answers will be current source. What is the answer? R is equal to infinity, open circuit. If it is a voltage source, what is the answer? R is equal to 0, short circuit. You have to remember these two sentences. Then we can solve the problem. Clear? Right. Now come to this one. Operate with one source. Operate with one source. Step 1. We should, if you have three number of sources, even though we have to operate with one source only. Step 1. That is the rule. That is the rule. If you have number of source 5, how many sources are there here? Only 2. Only 2. If he has given 3 sources, if he has given run with only one source, the other 2 are non-operative. The other 2 are non-operative. We have to run with only one source. We have to run with remaining all other are non-operative. Remaining all other are non-operative. Run with only one source. Remaining all are non-operative. But here, how many sources are there? Only 2 sources. 1, 2. That's why run with one source. Operate with voltage source, that is 20 volts. And non-operative current source, that is 5 amperes. Replace current source by their internal resistance. Open circuit R is equal to, that is the question. Step 1. Run with only one source. Run with only one source. Then only you will get the marks. You won't get the answers. You won't get the answers. Answers రావాలి అంటే compulsory you have to follow. Compulsory you have to follow. Run with only one source. Your wish. If you want to run with 5 amperes, run with 5 amperes. If you run with 20 volts, run with 20 volts. Your wish. You can step one, you can take any one. If you want to run with 20, run with 20. If you want to run with 5, what is the non-operative? Voltage source. What is non-operative? Voltage source. This is the sentence. Then draw the diagram. See the original diagram. Depending upon this sentence, we have to draw the diagram. So this is the time. Is open. Current source is, what is the value here? Infinity. What is the value here? Infinity. Current does not pass. Current. This is the diagram as per sentence. As per sentence, this is the diagram. Now, for this diagram, we have to apply mesh and nodal analysis, get the current through 4 ohms. Get the current through 4 ohms. Apply any 2 methods, your wish. Mesh analysis or nodal analysis, and get the answer. Get the answer. Which answer? Current through 4 ohms. Call it as I4 single dash. Call it as I4 single dash. I4 single dash. Right. Can I remove this last loop? This loop will remove cheyacha. We can remove this one. Why? Because current does not pass in this one. So we can remove the last loop since current is 0. Then we'll get only single one. Only this diagram. Modify circuit diagram will be, this is the, I have removed the second one. Why have I removed the second one? It is open circuit, there is no current, so we can remove the loop. Only, it is called a modified circuit diagram. It is called a modified circuit diagram. Now we can apply, we cannot apply nodal method. We cannot apply. Why we cannot apply nodal method? We don't have a junctions. We can apply only one method. What is that method? Mesh method. Applying KVL to mesh. 20 is equal to 6I1, 4I1. This is called I1. This is called assumption that clockwise direction. Unknown current is I1. Yesterday we have discussed. Mesh method. clockwise direction assumption. The unknown current is I1. Applying KVL to mesh, we get minus to plus 20. 6 into I1, 4 into I1. These two are in series. These two are in series. In series, current is same. In series, I1, I1. So therefore, 20 is equal to 10 I1. Therefore, I1 is equal to 2 amperes. What is current in 4 amperes now? 2 amperes. This I1 is called, give the new name called I4 ohms single dash. I4 ohms single dash. To remember, this is called step 1. This is called step 1. This is the procedure. Step 1 procedure. We need to find out the current in 4 ohms. We need to find out the current in, run with only one source. That is the condition. Run with only one source. Find the current through 4 ohms. Find the current through. This is called step 1. This is called step 1. What is step 1? Operate with 20 volts and non-operate current source, that is 5 amperes. It is replaced by their internal resistance, a short open circuit, R is equal to infinity. Draw the diagram. Draw the. So this is the diagram. After seeing the diagram, can you modify the circuit diagram? Yes, I can modify. How can I modify? Because I can remove the last loop. Why I am removing the last loop? Because current is 0. So we can remove the last loop. It is called a modify circuit diagram. Is there any option to modify? Check it. If there is option, modify. If there is no option, apply nodal and mesh method. Apply nodal and mesh. If there is no modify. Now it is there is option for me. There is an option for me to modify. There is option for me to modify. Yes, I have modified. After modification, check. You can apply any one method. Which is the best method? Mesh method. Because we cannot apply nodal method. Nodal method, if you apply nodal method, I need a junctions. We don't have a junctions here. So only possible is mesh method. Only possible is mesh method. Apply mesh method. Assumption clockwise. Clockwise or anti-clockwise. My assumption is clockwise. The unknown current is I1. Get I1 answer. The current through 4 ohms. Now change the name. Instead of I call it as I4 ohms single dash. I4 ohms. Is there any doubt in step 1? Run with only one source. Find the current through 4 ohms. Find the current through I. Now step 2. Now run with other source. What is the other source here? Current source. Step 2. Run with other source. The other will be non-operative. The other will be non-operative. Now make a sentence here. Now make a sentence here. Operate with current source 5 amperes and non-operative voltage source. Non-operative voltage source, that is 20 volts. It is replaced by their internal resistance. Short circuit, R is equal to 0. If you get voltage source, R is equal to 0, short circuit. This is the answer. If it is a current source, what is the answer? R is equal to infinity, open circuit. Draw the diagrams. After making a sentence, draw the diagram. After making a sentence, draw the diagrams by seeing the original diagram. By seeing the original diagram. Now go for the original diagram. This is the diagram. Yes, short circuited. Voltage source is short circuit. What is the value of short circuit? R equal to 0. R is equal to. This is the standard diagram. After making a sentence, after making a run with this source. If you run with this source, what is the current in 4 ohms? This is the question. If you run with 5 amperes, what is the current through 4 ohms? Step 1. If you run with 20 volts, what is the current in 4 ohms? 2 amperes, confirm. If you run with 5 amperes, what is the current through 4 ohms? We have to find out. We have to find out. Apply any kind of method. I applied nodal method. I applied how many junctions here? 1, 2. Right. Now this is the junction point. Call it as A. call it as A. And this is called A, zero voltage. Yesterday we have the reference node. Yesterday we have discussed reference node A. Applying KCL at junction A. Applying KCL at junction A. The assumption for this one is A called I1. This is called I2. But cannot say this is I3. I cannot say this is I3. I cannot say this is I3 because he has given current in this branch. That's why no assumption. That's why no assumption. Conform towards the junction 5 amperes. Conform towards the junction 5 amperes. We should not consider I3 because he has given the current source. He has given the current source. He has given the current source. We should not assume away from the junction. We should not assume away from the junction because he has given the current source in the branch. Because he has given the current source in the branch. If he has not given the current source in the branch, then there is assumption. Then there is assumption I3. Then there is assumption I3. No, we should not assume. Only I1, I2. Away from the junction. Away from the, then you apply KCL at junction A. Then you apply KCL junction A. Minus I1, minus I2, toward the junction, plus, toward the junction, plus, away from the junction, minus 1, away from the junction. Right. Now convert into V by R. I1 should be converted into V by R. I2 should be converted into V by R. Right. Now tell me this is the V by R. This is called unknown current. What is called? V1. V1 by 6. Is it correct? Now tell me this current. V1 by 4 is equal to 5. Is equal to. Now solve this problem. We get V1 is equal to 12 volts. We get V1 is equal to 12 volts. Now I want current in 4 ohms. Now I want. Therefore, the current through 4 ohms is I2. Which current is flowing here? I2 is flowing. V1 by 4. Which current is flowing through 4 ohms? I2. Assumption is I2. What is I2? What is V1? What is current? They give the new name for I2. I2 is equal to new name I4 double dash. This is the 3 amperes. If you run with 5 amperes, what is the current through 4 ohms? 3 amperes. If you run with 5 amperes, what is the current through 3 or 4 ohms? 3 amperes. If you run with 20 volts, what is the current through 4 ohms? 2 amperes. So 2 sources completed. One is 20, the other is 5. Clear all of you? Once again, I am telling the second point, step 2. Listen very carefully. Once again, operate with current source, that is 5 amperes, and non-operative voltage source, that is 20 volts. Replace voltage source by their internal resistance. What is the answer? Short circuit, R is equal to 0. Draw the diagram. Draw the diagram. See this one. Short circuit voltage is short circuit. What is the value? R is 0. Right. Now apply any one method. Mesh or nodal method. We can apply any one method. You will get the answer. What is the answer? Current through 4 ohms. If you run with 5 amperes. If you run with 5 amperes, what is the current through 4 ohms? You have to solve the problem. Apply any method. Mesh method or nodal method. So what method I have applied? Nodal method. Now 2 junctions. 1, 2. What is junction? Minimum 3 elements. 1, 2, 3 junction. 1, 2, 3 junction. Is okay element. This is the element. This is the element. So 2 junctions. Confirm. Next, take 1 as the reference node. The value is 0. The value is 0. So this is called 0 voltage. This is called 0 volt. This is A, V1. Now make assumed current from the junction. Now make assumed from the junction away. Always away. Always away. The assumption are away. The assumption are away. I cannot assumption I3. Why I cannot assumption I3? Because he already given toward the junction. Towards the current is flowing toward the junction. I cannot assumption I3. It is toward the junction. Now applying KCL at junction A. Applying KCL at junction A. Minus I1 away. Minus I2 away. Toward the junction. See this one. Toward the junction 5. Current. This is also current is equal to 0. Now shift it. I1 plus I2 is equal to 5. Now convert into V by R. Current V by R. Current V by R. Now see this branch. In this branch, V1 by 6. Now see this branch. What is the branch formula? V1 by 6. V1 by 6. Now this one. V1 by 4 is equal to 5. Now solve this problem. What is the answer? 12 volts. What is the answer? 12 volts. So, but I want current in 4 ohms. But I want current in. Therefore, the current through 4 ohms is I2. What is I2? V1 by 4. V1 by. So, V1 by 4. What is V1? 12. 12 of 3 amperes. So, this is the current flowing through 4 ohms. If we run with 5 amperes. Run with. There is no step 3. We have only 2 sources. Step 1, 20 volts. Step 2, 5 amperes. If you have one more source, step 3. If you have 3 sources, step 3. Only 2 sources, step 1, step 2. The last step is step 3. Last step is step 3. Step 3, last step. When 2 sources running at a time, what is the current through 4 ohms? This is the question. When 2 sources are running at a time, what is the current through 4 ohms? The answer is step 1. What is the current? See the direction. Step 1. Downward or upward? What is the name given? I1 is equal to I4 single dash. Is equal to I4 single dash ohms because of 20 volt source. Because of 20 volt source. I4 single dash ohm is equal to I1. It is in downward direction. Check step 1. Check. E direction check just codes. Check this direction in step 1. In step 1. Check this direction. See this one. I1 direction downwards. I1 are the same. You have to see this one. I1 direction. You have to check the step 1. This is called direction. Downwards direction. Downward direction. We have the game. What is the other name for I1? What is the other name for I1? I4 single dash ohm. I4 dash. We have given the name. We have given the. It is in downward direction. How you got this downward direction? By seeing step 1. By seeing how you got this direction downwards? How can you say? By seeing step 1 diagram. By seeing step 1 diagram. I1's downward direction. Now see the direction of step 2. Now see the direction of it is downward upward. It is also downward. It is also. How can you say it is downwards? See the step 2 diagram. See the step 2 diagram. Both are in the same direction. I1 and I2. So we should add same direction plus. When 2 sources are running at a time, this is the current flowing. 1 plus 3 is equal to 4 amperes. 1 plus 3 is equal to 4 amperes. 2 వచ్చింది అనుకుంటా కదా మనకు 2 వచ్చింది ఇక్కడ 2 నా 1 2. So 2 plus 3 5. So this is a mistake. 2. Okay. So this is the procedure. Can you do the problem? Same. This is the concept. This is the concept. But you should know mesh analysis and nodal analysis knowledge. If you know the mesh and nodal analysis knowledge, you can solve the problem. You can solve the problem. So you have already kept these notes. You can change this to the last bit. You can change it to instead of 1, it is 2. You can change it. Clear? Anything? Just go on. Let's. Sir. Okay.